All right, we took a look at a little bit of what's going on at the beginning of this section last time, and also a little while back with another purpose in mind when we talked about the AC method. So when we were factoring before in our AC methods, we always had the coefficient of 1 for A. And so I mentioned when I did that it's almost like, like smashing a fly with a hammer kind of thing. Like it's overkill. We don't really need to do it that way. But the AC method is really helpful when it comes to things that don't have that coefficient of 1. So that's what we're going to look at today. So the first thing you should always do when you're factoring polynomials is look for greatest common factors. Sometimes there's a number that you can always pull out of everything, or a variable or something. After you're looking for the greatest common factor, your options are either the trial and error method or the AC method. And again, when I get to tests and so forth, it's not going to tell you which one you have to use. But I'd like to present you with both. Trial and error becomes a lot more difficult with these types of problems. Not impossible, but there's a lot more choices to make, a lot more variability, and it can make it a lot harder. So the first thing we're going to do on these is we are going to use trial and error, just so that you can get a sense of why it's a little tricky. So on each one of these, we're starting with that first, bullet point, if you will here, whatever, which is looking for greatest common factor. So 5y squared minus 45y plus 90. What do they have in common? A 5. So on this one, when I take the 5 out, it actually creates a y squared that has a coefficient of 1, and that's very friendly. They're not all going to do that. 45, take out 5, I get 9, so 9y, negative 9y in the middle. And then 90, take out 5, I get 18 is right. Okay, so if you take it out, you're dividing. 90 divided by 5 is 18. So if we're using trial and error, what that means is that the next step is to simply write the two sets of parentheses. And this one's not so bad because, again, we have a coefficient of 1 really now in front of the y squared. So we have y and y. The sign at the end is positive, which means the signs in the middle of my binomials are going to match. And the sign in the middle is negative, so they're going to match and be negative. So we have a negative here and here. Okay, so far so good. So when I'm looking at this method, I need two numbers that multiply to 18, and they add to 9. 6 and 3. Does everybody agree? So what you're checking for mentally, or written down if you wish, is that these two multiply to 18, which they do, and that when I do my inner and my outer terms, I end up getting negative 9. Why? And they do. So this one's trial and error wasn't so bad. But the reason it wasn't is because when I really factored out the greatest common factor 5, I ended up with a 1 in front of y squared. So that's not going to happen on the second one. In fact, on the second one, there isn't a greatest common factor to pull out, right? There's not. So if we're going with trial and error, which we will on this particular one, this set of ones anyway, we'll draw our parentheses. And at the beginning, instead of having x and x, I'm going to have two numbers or two values that multiply to give me 3x squared, which means I do have an x and an x, but one of them actually has to be 3x, and it doesn't matter which one, because that's the only way I get a 3 at the beginning, is that one of those has to equal 3, because 3 times 1 is 3. Good so far? Okay. This one is a little friendly because the end of this has a positive 8. Positives mean my signs match. Signs matching means that it doesn't matter how I put the signs in because they're the same. When signs don't match, it gets harder. So for right now, my signs match, and the middle term says they're negative, so I have some signs that are both negative. Because so far I have not had to make any choices. Everything is the only option that it is. Right? That's about to change. The number 8. I can get the number 8 by doing 1 and 8, or by doing 8 and 1, or by doing 2 and 4, or by doing 4 and 2. Right? There are 4 options. And the reason you might be thinking, like, why should you write out 1 and 8 and 8 and 1? Well, the reason I did is because whatever I put them in, they're going to end up being different. So if I put a 1 in the first spot and an 8 in the second spot, the inside and the outside terms are different than if I put an 8 in the first spot and a 1 in the second spot. And the reason they're different when they weren't different before is because when I'm looking at the outer term has to be multiplied by 3x, not just x. So let me try those two numbers just so you can see it happening and why that actually ends up giving you different pieces. So if I put 1 and 8, this one and then this one, I get negative 1x and negative 24x. So first of all, that's negative 25x, and that's not what my middle term is. It's supposed to be negative 14, right? So if I switch my 8 and my 1, which is what I would do next, you'll see in the inside now I get negative 8x, and on the outside I get negative 3x. Well, at the very least, you should register that that's not negative 25, which is what I got a minute ago. That actually gives me negative 11x. And that's not what I want either, right? So what I've done so far is I've eliminated these choices. 1, 8 and 8, 1, neither one work. So now I'm back to trying something different. So I need to not use 8 and 1, I need to use 2 and 4. So let's use the 4 and 2 first. So if I do 4 and 2 in this order, I have negative 4x and negative 6x. Does that work? And I'll get negative 14 by doing that. So we try the opposite, 2 and 4 here. In the middle I have negative 2x, and on the outside I have negative 12x. Jackpot after 4 tries. And this was an easy one. Now, you might get lucky and just pick the right one at the beginning. Like, that's a possibility, right? That's what trial and error is. Trial and error means that I might pick the right one to begin with, kind of like the lottery. You might pick it, all right? The more options there are, the less likely you're going to pick it first. If you have a list of things you're trying and you go down your list, you're at least kind of organizing your thoughts and eliminating things as you go. As we work through these, they will eventually work, and if they don't, then it means that they're prime, right? So you think about the number 5, for example. 5 is considered a prime number because the only numbers it divides by are itself and 1. 6 is not prime because it divides by things other than itself and 1. So if you have a polynomial that does not factor, hence it does not divide by something else, then it's considered prime as well. You have a question, Jenna?
Wait, are we trying to get negative 12 or negative 14?
We're-
In the equation it says negative 14.
We are. And when we add negative 2 and negative 12, we have a negative 14. So you're right. That's what we're looking for, is for both of them to combine to the negative 14, yeah. So this is our factoring after trying 4 things. Okay. Let's take a look at the next one. The next one has 7x squared minus 5x minus 2. So much like the last one, I don't have anything much to do on the first one except to write in 7x and x. And the reason that's happening is because just like on the last one where the first coefficient was a 3, this coefficient is a 7. They're prime. If the number had not been prime, it started out, say, 6x squared. We have already to make a choice. Do we put 6x and x, or do we do 2x and 3x? Okay, so the fact that the 7x is prime, the 7 part, is actually really good. Unfortunately, this sign here at the back is not so good. And the reason that that negative sign is not so good is because we have 2 choices, right? If the sign at the back is negative, it means I have a positive and a negative. Now, when we did it before, it didn't matter. The reason it didn't matter is because my coefficient of the x squareds were 1. Here it matters. And it matters because if I pick wrong, the signs will be multiplied by the wrong values, and I end up getting the wrong numbers. So I just made a choice, right? That might not be the right one. Are you with me? So this is something to keep in track in your mind of, like, when did I actually have to choose something? Well, I chose something right there. I put a negative in the first spot and a positive in the second spot, and I may need to go back and change that later. Now, it's easy to see when you have to change it later, so that's kind of a cool thing. Yep, Cameron?
So if there's a negative in the second slot, it's going to be a negative.
Yeah. It's always, because the 2 numbers that multiply here have to be numbers that multiply to negative 2. And I can't take two negatives and get -2 or two positives and get -2. One of them has to be positive, the other one has to be negative.
But if it's positive, then it's both
If
negative?
it's positive, you look at the middle term to make your decision. That's what we did on this problem. It was positive at the end on number 2.
Uh-huh.
So we looked at the middle term. They're both negative, so they're negatives. Yeah. However, on this one, there is something nice that happens. I don't have lots of choices. I have 2 and 1 or 1 and 2 here. Can you see that green okay? I think maybe we'll switch to a darker color for the next slide. 2 and 1 or 1 and 2. So we're going to pick one, and we're going to see if it works. So let's say that we pick 2 and 1 just because I listed it first. And let's try what happens in the middle and on the outside. So in the middle, I have -2x. And on the outside, I have positive 7x. What will that give me if I add them together? It will give me 5x. Is that what I want? No, but it's really close. How is it different than what I want?
It's the wrong sign.
It's the wrong sign. So if you get the right numerical value and simply the wrong sign, what it meant is that the choice you made when you put the signs in was the wrong choice. But it's easy to fix. So you go back and you change it. And you say, okie dokie, well, I really wanted the first one to be positive and the second one to be negative. And if I do that, I will get positive 2x in the middle, and I will get negative 7x on the outer edges. Does that give me my negative 5x that I want? Yep. So now I'm done. I don't need to test the other 1-2 arrangement because I found the one that I wanted before I got there. Okay? So if the wrong value is happening completely, it means that you've got values in the wrong places. Like they shouldn't be there. You got to switch them or change them out entirely. If it's only the sign that's wrong, it means your signs are in the wrong places. Number 4 is kind of interesting. What is it about number 4 that's different than all the other ones we've done?
The first term is negative.
Sorry, I'm looking at this tree outside. You guys look at this. That is insane. All right, yeah, the first one's negative. Thank you, Harrison. I'm so distracted by the windows at the moment. The first one is negative. So it's not that we can't deal with the negative and deal with it as we've done before, but it's kind of like, why should we have to? So here's what we do. We take the negative out. And if we take the negative out, we got to take, all the signs have to switch. So if I take the negative out of negative 3w squared, it's positive 3w squared. If I take the negative out of negative 4w, it's positive 4w. And if I take the negative out of positive 4, it becomes negative 4. So when I pull a negative out in front of things, I change all my signs. And it makes it a lot easier to do it. You want that to happen. You do not want to have to deal with that negative where it was, okay? So at this point, aside from the negative that's showing up on the outside, everything else can be drawn with parentheses. So we're looking at this spot right here, and we have 3w squared. Well, we've had 3 in the first location. I've got 3w and w, or you can write it w and 3w. It doesn't matter. That's not a choice that you're making because it doesn't change it if you switch it. Okay, you haven't done anything to change. The sign at the end is a choice, though. It's negative, right? So we'd kind of like to figure out which way to put it in, but you really don't have a good way of doing that. You're just going to pick one option and see what happens. So let's pick positive and negative. And if it doesn't work out with the signs like the last one didn't, we'll switch it. Good so far? Okay, this number 4 at the end is less than ideal. And the reason it's less than ideal is much like over here where I had the number 8. 8 was less than ideal because I had choices, right? I had 1 and 8, and I had 2 and 4. The number 4 has choices as well. It has 1 and 8, 8 and 1. I don't mean 8s. Sorry, 4 is what I meant. 1 and 4, 4 and 1, or 2 and 2. Okay? There's nothing special about the order I put them in. I just listed them. So somebody pick one for me. 2 and 2. Okay. So Reese picked 2 and 2, and we will check and see if it works. So if I do 2 and 2, I try the inside, gives me 2w. I try the outside, and I get negative 6w. What do those two add to?
Negative 4.
They add to negative 4w. Is negative 4w what I wanted?
Yes.
No.
No. Okay. I wanted to compare it to here. So close. But you know what? So close is actually okay. So close means all I need to do is switch my signs. So if I switch my signs, then I'll be good. So this one should have been negative and this one should have been positive. I get a negative here, a positive here, and now I have positive 4w. So this is my factoring for this problem. How could I check to make sure any of these are right? By multiplying it back out, right? I could take the answer that I have at the end. I can multiply everything back out by multiplying first, outer, inner, last, the whole shebang. I could distribute the negative back through. If I was doing this problem number 1, I could distribute the 5 back through, clean it all back up, and see, do I in fact get what problem I started with? And if I did it right, I will. Did you get all the pieces written down, Haven? What's wrong?
3w plus 2.
It's not plus, it's times. We're always multiplying. Yeah. So 3w times the 2 to give me the 6w. No worries. Okay, so whether you like the AC method or the trial and error method is not my question. My question is, do you see why the trial and error method is more complicated when the coefficient isn't 1? Yes. Okay. That doesn't mean you might not still like it and choose to use it, and that's fine. It just means it's more complicated, right? So the AC method becomes more useful on these problems because the trial and error method is more complicated. So we're going to do a couple of the examples, not all 4, but a couple of the examples with the AC method so you can see how it works out, because it does look a little bit different than it did before when I only had a 1 in front of the x squared or whatever squared. So we're going to use the same problem, number 2. It was 3x squared minus 14x plus 8. Okay? And we're going to use the AC method. So that means we're going to multiply a times c, but this time a is actually 3, and c is 8. So 3 times 8 is 24. And your b value is negative 14. Okay, so far so good? Now this was the point previously where it's like, why bother? Those were the numbers I was going to write at the end anyway. Well, they're not now. So I need 2 numbers that multiply to 24. That means they have to have the same sign, right? I can't have a positive and a negative and I get positive 24. Signs have to match. And they have to add to negative 14. So what are some options? Let's actually just write a few of them down. What are some options of things that multiply to 24?
Negative 12, negative 2.
Okay, so 1 and 24 would be 2 of them. I'll leave the negatives off for just a moment, Haven, but 2 and 12 would be another one. What else? 8 and 3. And 6 and 4, 4 and 6. Okay, so these are the 4 options that I really have. Haven already hit on something that I hadn't said, but you're okay. They do need to be negative, right? Otherwise, I'm not getting a negative 14 in the middle. So whichever pair it is here that I pick, it's going to be negatives. So which of these 4 gives me negative 14 if you add them together?
12 and 2.
Yep. Negative 12 and negative 2 give me negative 14, right? Those are the ones that I want. They multiply to 24. They add to 14 with the correct sign, negative. So over here on my original problem, I take this and I rewrite the negative 14 in the middle as the negative 2 and the negative 12. And again, it doesn't matter what order they're in. So I'll do my 2 first and my 12 second. But if you write them the other way, it's fine. And then I have plus 8. All right, we're factoring now by grouping. So I group the first 2, I group the second 2. The groupings always are really nice with the AC method because they are always going to work right where they are. 3x squared and 2x, what do they have in common? An x. I pull out an x and I'm left with 3x minus 2. 12x squared and 8. I'm sorry, 12x and 8. What do they have in common? 4. And if I only take out like a positive 4, I'd like for you to notice that I've got a problem. Can somebody tell me what problem I have?
It'll be, the sign will be wrong.
The signs are wrong. So on this one, the 3 is positive, the 2 is negative, and on this one, the 3 is negative, the 2 is positive. Do you guys see that? So I need my signs to match just like I need the values to match themselves. So what we actually needed to do instead is, instead of taking out a positive 4, I need to take out a negative 4. So if I take out a negative 4, I have the 3x. And if I take a negative 4 out of positive 8, I get a negative 2. Right, it's division. When I'm taking something out, I'm dividing. 8 divided by negative 4 is negative 2. And that is what I want, because these two do match, which is exactly what we were seeing before. I will have a matching piece in parentheses. So I take the matching piece out, 3x minus 2, and I'm left with the pieces that are not matched up, the x and the minus 4, and I'm done. Any questions on that? Okay, we're going to try the same thing again with the 7x squared minus 5x minus 2. So the AC method is a times c. A is 7 and c is negative 2. So 7 times negative 2 would be negative 14. And the b value is negative 5. So far, so good. So just like before, I'm going to write down all my possibilities of things that multiply to 14, and I start out with something really exciting, 1 and 14. Now, the kicker is, it's supposed to multiply to be negative 14. So how am I going to get these to give me a negative 14 instead of a positive 14? What's that? Okay, so we're going to get to that in just a second, but let me pull out something you said that you didn't necessarily intend. One of the numbers you told me was negative and one was positive, right?
Yeah.
Okay, so at some level, one of them has to be positive and one of them has to be negative, whichever ones that are, if they are. So when I have these options, I actually have a negative 1 and a positive 14, or a positive 1 and a negative 14. And then I also have the 2 and the 7 that you mentioned, Caden. So I have a negative 2 and a positive 7, or a positive 2 and a negative 7. Does everybody see where all 4 of those combinations came from? Those pairs? I need to pick the pair now that adds to negative 5. So which of those add to negative 5?
Negative 7, 2.
Yeah, my very last one actually that I wrote down, right? The negative 7 and the positive 2. Those add to negative 5. So that's the one I want. So over here in the middle, I will not write negative 5x anymore. I will write it the way that I did before. So I'm going to use it in the order that Harrison had said, which was the negative 7 and the positive 2. Not because it matters, but because I want to show you that it didn't. I actually used it in the other order last time. And then I have the minus 2 at the end. So on the first set, 7x squared and negative 7x, what do they have in common? 7 and x, right? They both have a 7 in them, and they both have an x in them. And if I take 7x out of 7x squared, what do we get? What was that? Yeah, so I get an x at the beginning, right? And if I take the 7x out of the negative 7x here, I get the minus 1 in the middle, or second. Yep.
Wait, if you had a 7x squared and then plus 2x, would you still get 7x?
Yeah, what would happen? Actually, let me do it in just a second so you can see what would happen, just to show that it will still work, but it'll do it in a different order. But it will still work. On the next one, 2x and minus 2.
X.
They have a 2 in common.
Oh, yeah.
Yeah. So they both have a 2 in them. We'll pull the 2 out. 2x divided by 2 is x. Negative 2 divided by 2 is negative 1. So far, so good? So here's that x minus 1 that they have matching now. And then the missing pieces that don't have a matching pair are the 7x and the plus 2. So I'm glad you asked that question, Cameron, because it doesn't matter, and I keep saying it doesn't matter, but I've never shown you that it doesn't matter. So let's say that when you originally did it, we put it in as the 7x squared, and I put the 2x first and the negative 7x second, and then I had minus 2. Okay? So all I did is I just wrote these numbers in opposite order of what I did the first time. Did everybody see that? I just wrote them in the backwards order. Because it doesn't matter, and here's what happens when you try. 7x squared and 2x don't have a 7x in common, but they do have an x in common. And if I take it out, I get 7x plus 2. And the last piece, the 7x and the negative 7x and the negative 2 have a negative in common. So I pull out a negative 1, and I have 7x plus 2. So they're switched, right? The part that's in parentheses, the 7x plus 2, is the part that was loners last time. And vice versa. So my 7x plus 2 is written first. And then my x and my minus 1, I would write second. And it doesn't matter what order they're written in. That is still the same product. Any questions on that? So it really, truly does not matter what order you pick. So as you're doing these homework problems, you're welcome to use trial and error. That's fine. As you're using it, if you find yourself getting frustrated because you've tried everything you can think of or something like that and it's still not working, you might want to just go ahead and suck it up and do the AC method, even though it takes a couple more steps. Sometimes trial and error is great because it works really quickly. And it is, and that's really great when it does. Sometimes it's just a beast and it just doesn't work quickly at all. So those are two methods for doing this. We have a couple other things in this section we're going to take a look at. Some special factoring forms. One of our special factoring forms is called a perfect square trinomial. And what it looks like is it's what happens when I have two values that are identical multiplied. So if I have a plus b squared, which means a plus b times a plus b. So when I have binomial times a binomial and the binomials are the same, we can actually multiply this out just fine. There would be nothing wrong with foiling this out. But it's very interesting that when you FOIL this out, the inside and the outside terms are the same. Right? Inside's AB, outside's AB. So as I'm multiplying them out and then I'm condensing them, so I'm going to actually write that out up here just so that we can see it. That's what it looks like if I actually multiplied it out longhand. But the reality is that it will always then condense to a squared plus double the middle term, 2ab, plus b squared. So a perfect square trinomial always has this form, a squared plus 2ab plus b squared. It's kind of a nice one because if you don't notice it and you just distribute and multiply everything out, you'll still get there eventually. It's not going to hurt anything. So it isn't one that's sort of like, if I don't memorize this, there's going to be a problem I can't do. It's actually not at all. The next one kind of is. So the next one is a difference of squares, and the difference of squares looks like a plus b times a minus b. Actually, I think I'll write this one underneath here for some more space. So when I have two values, where one of them, like a binomial, where the two values are added, multiplied by the binomial where the two values are subtracted, this is called a difference of squares. And the reason it's called a difference of squares is because of what happens when you multiply it out. So like I did just a moment ago, notice if you look at the inside and you look at the outside, they're the same, except one's positive and one's negative. So what happens when you take 5 plus negative 5, 7 plus negative 7, negative 222 plus positive 222? Cancel out, right? They get 0. So the inside terms here and the outside terms here are the same, but with opposite signs. They add to 0. So all you end up being left with is the first term squared minus the second term squared. Now, for what we're doing, if we were multiplying it out like I just did, okay, great. I could have done that with the first, outer, inner, last. The problem is that if you start here and you try to use any of the factoring forms that we've been working with, they come up short. I don't have 3 terms to factor. I don't have 4 terms to pull out pieces that are the same for factoring by grouping. I don't have enough terms to use any of the things that I've been using. What I do have to recognize is I have the first term squared, difference means subtraction, and I have the second term squared. And when that happens, it will always factor into a plus b and a minus b. So let's see some examples where this comes into play, and then we'll combine a few of the things that we've been working with. So on the first one, hopefully you recognize that 81 is a perfect square. I do hope you recognize that. 81 is a perfect square. What is it squared? 9. So this is 9 squared in the ending part. And the middle, 18, is actually 2 times 9. So it fits the form of a perfect square trinomial. Now let's say you didn't recognize that. You didn't mark any of those things down. We're back at square one. You'll be just fine. Trial and error works really nicely because the coefficient at the front is 1. So I have u and u. The signs are beautiful because they're all positives. I need two numbers that multiply to 81 and add to 18. Hines, right? And sure enough, it's that same perfect square that I saw before. Okay? So again, I mean, I mentioned it because it is a thing, but not because it actually really drastically affects your life. Not even your math life. Not even your life in intermediate algebra. Like, it just doesn't. You can get around without knowing that particular one. So the next one, not so much. I don't have 3 terms. I don't have traditional factoring techniques that I've been using. I have 2 terms. But I should recognize, again, like I said with the 81, that 25 is a perfect square. 25 is 5 squared. So I'm going to write it that way. I have one number squared minus another number squared. And what this difference of squares formula says is that I should be able to write this as 2 binomials. One of them says 5 minus w, and the other one says 5 plus w. That's the perfect square, or the difference of squares formula. That's what it is. I just have to identify what's being squared. 7 also has 2 terms, but I need to identify what's being squared. I see another 25 here, right? So you might recognize that the 25 is 5 squared, but what that actually means is that 5 and y are both being squared. So the first thing that's being squared is not 5, it's not y, it's 5y, all of it together. You need both pieces. How about the end? How do I get 49? 7 squared. So again, utilizing the formula for difference of squares, I should be able to set up my 2 sets of parentheses. One of them says 5y minus 7, and the other one would say 5y plus 7. The identification step takes a minute sometimes. It's not always super direct. Also notice on the one that's in the middle here, what's on the middle of your page, the 25 minus w squared, it doesn't have to be that the variable's first. Right? It doesn't. A lot of times our variables are listed first, but they don't have to be. The formulas still work even if the variable is the part that's subtracted at the end. Okay, last couple of examples. We're going to combine several things from what we've been looking at in this section. So one of the things, in fact, the very first thing in this lesson, I said, first thing you should do whenever you see a problem is you should do what? Take out the GCF. You look to see if there's anything that factors out of everything listed. So we need to go back to remembering that piece because these actually have that in play. 3u squared minus 30u to the 6th, u to the 7th and then u to the 6th, plus 75u to the 5th. So think about the coefficients first. What numerical value do all my coefficients have in common? 3. I'm going to take a 3 out. How many u's do they all have in common? They have 5. So I'm going to take out a u to the 5th. Now, taking things out is equivalent to dividing. So I had 3u to the 7th, and I take out, or I divide 3u to the 5th. What's left from that piece only? U squared, or u to the 2nd. Yep. Right, the 3 gets removed completely. If I give u to the 7th and I have u to the 5th pulled out, there's 2 u's left, so that's u squared. What about in the middle? negative 10u. So far, so good. How about at the end? What? It is 25. Okay, so again, maybe you notice that the 25 is a perfect square, and so you recognize that you're dealing with something in this category on perfect square trinomials, and maybe you don't. But the reality is that this does work nicely for factoring with trial by error because the u squared, that's in the parentheses now, has a coefficient of 1. So that's the one that I'm going to utilize. 2 sets of parentheses for the parts that are in parentheses. I have a u and I have a u. What are my signs?
I think you wrote a 2 instead of 5.
Oh, I did. Thank you. I've been having some problems with my exponents today. My other class too. What are my signs?
-5,
Okay, my signs are both negative, right? Because I need that to multiply to be a positive at the end. I need it to add to be a negative in the middle. And say it a little bit louder for me, Cameron.
5, 5.
5 and 5 will do it. I need two numbers that multiply 25. It's 5 and 5. That add to 10. That's 5 and 5. So I end up with this as my factored expression. But number 9. What do they have in common, all the pieces? What can I factor out?
2y squared.
Okay, they're even, so I've got a 2, and they all have at least a y squared. So I have 6y to the 4th, take out 2y squared. What am I left with? 3y squared. 20y cubed, take out 2y squared. 10y. And then, there's a positive, 14y squared, take out 2y squared, 7. You're welcome to do trial and error. I'm going to do one more AC method just because that coefficient is not the number 1, like we've been looking at. So everything I'm about to do ignores the 2y squared. It's already factored out. I'm done with it. I don't need to do anything else with it, but just carry it along to the next piece. So I need a times c of the part that's in parentheses. So a is 3. And c is 7, which multiply to give me 21. And then b is 10. So I need the numbers that multiply to 21. Well, obviously I have 1 and 21. What else do I have?
7 and 3.
7 and 3. I'll do it in the order you give it to me. That's it, right? Not a lot of choices. You might notice that the signs in the problem were all positive. So all of these signs are also positive, right? So this is the one that does what I want it to, right? Because I want it to multiply 21, which this does. And I want it to add to 10, which that one does. So as I'm looking at this in the middle, what it means is that I rewrite the first piece and I rewrite the last piece. And in the middle, I break the 10y apart. I break it apart in whichever order you wish into 7y and 3y. Okay, that's a replacement step that's appropriate because 10y is 7y plus 3y. Didn't change any values, I just wrote them in a different way. And then I'm going to group them together. So, again, like I mentioned before, the 2y squared gets rewritten. 3y squared plus 7y. Actually, I'm going to start with a bracket here just to set it apart. What do 3y squared and 7y have in common? A y. So I pull out a y. I'm going to be left with 3y plus 7. Now the next one, 3y plus 7, it doesn't have anything in common, but there's always something in common. It's a 1. So I'm going to pull out a positive 1, and then the 3y plus 7. Which is not a bad thing because I already had a 3y plus 7, right? They match. That's what I was looking for, is I was looking for them to match. So, I've got my 2y squared written one more time. And then I've got, you don't necessarily need the brackets now, but the pieces that match, the 3y plus 7 can be written next. And then I've got the pieces that don't match, the y and the plus 1. And if I wanted to know for sure How could I make sure I did it right? There's no plugging it in. There's nothing to plug into.
Go back.
You could go backwards. You could multiply it all back out, right? Yeah, you could multiply it all back out. You have the ability, if you wanted to take the time to do it, especially on the ones that maybe you weren't so sure you did it right, to check every single problem if you want to. All right.